Let me tell you something that sounds impossible. AI isn't running out of ideas. It's running out of electricity. Right now, the richest companies on Earth are racing each other. Not for the smartest model. Not even for the best chip. For raw power, gigawatts of it. And guess where that race ends up? Nuclear reactors. Stick with me here. By the end of this, you'll get why a chatbot company ended up in the nuclear business. Let's start simple. You've asked ChatGPT a question today, probably. For years, there's been a claim floating around. One ChatGPT question, 10 times the electricity of a Google search. Everyone repeated that number. Articles, headlines, even climate reports. Here's the twist, though. Sam Altman himself came out and said, "That's wrong. The real number's much closer to a regular search. About 0.3 watt-hours. So, panic over? Nothing to see here? Not even close. Because that number was never the real story. The real story isn't one question. It's the training. Before ChatGPT answers anything, it has to learn everything first. Months of computers running non-stop, thousands of chips, zero breaks. And training one frontier model? That can burn through more electricity than tens of thousands of homes use in an entire year. One model, that much power. Now multiply that. Dozens of labs, all training bigger models, constantly, every single month. That's the real number nobody talks about. Let's talk hardware for a second, because this explains everything that comes next. Inside every data center, rows and rows of chips called GPUs. Think of one GPU like a tiny worker. Except instead of one worker doing one job, you've got thousands, all crunching the exact same problem at the exact same time. That's what makes AI possible. That's also exactly why it's starving for power. Every chip runs hot, genuinely hot. So hot, data centers need industrial cooling systems. Just to keep the whole thing from melting down. Thousands of chips running non-stop, generating heat. And cooling that heat away takes even more electricity on top. Now picture one data center like that. Now picture dozens of them, all built in the last 2 years alone. This is where the real war actually starts. OpenAI, Microsoft, Google, Meta, xAI, they're not fighting over chips anymore. They're fighting over gigawatts. And here's the part that should genuinely surprise you. You'd think easy fix, right? Just use solar panels, wind turbines, done. Nope. Here's why. Solar stops the second the sun goes down. Wind stops the second the wind stops. A data center training a massive model can't do that. It runs 24 hours a day, 365 days a year. It can't pause because a cloud rolled in over Texas. So these companies need something else entirely. Something that runs. No matter what. Day or night, rain or shine. Energy people call this baseload power. And only a handful of things on Earth actually deliver that reliably. Natural gas, hydro dams, and nuclear power. Which brings us to the part of this story that genuinely sounds like fiction. September 2024, Microsoft signs a deal. 5 years earlier, this would have sounded completely insane. They're bringing 3 Mile Island back online. Yes, that 3 Mile Island, site of America's most infamous nuclear accident, back in 1979. Here's the twist most people miss, though. Wrong reactor. The unit involved in that accident, Unit 2, has been sealed off for decades. The one Microsoft's actually restarting, Unit 1, ran safely for over 40 years. It only shut down in 2019, and purely for economic reasons. It simply couldn't compete on price against cheap natural gas at the time. Now, Microsoft signs a 20-year deal, reportedly worth around $16 billion. Every single watt that reactor produces, locked in for 2 decades straight. They even gave it a new name, the Crane Clean Energy Center, coming back online, targeting 2027. That one deal quietly set off what industry analysts are now calling a genuine nuclear arms race. Google moved next. Completely different approach. Skip reviving old plants entirely. Build brand new, small ones instead. Something called small modular reactors. Factory built, small enough to sit right next to a data center campus. Google partnered with a company called Kairos Power, committed to 500 megawatts of this brand new technology. The catch? Nothing like this has ever actually run commercially anywhere on Earth yet. Amazon took a third path entirely. $650 million buys an entire data center campus sitting right next to an existing nuclear plant called Susquehanna in Pennsylvania. Then, another $20 billion on top of that, turning it into a full-scale AI campus. And it doesn't stop there. Amazon also poured $700 million directly into a company building next-generation small reactors, securing the rights to potentially deploy up to a dozen of them. Then there's Meta. And Meta might genuinely be the most aggressive of all four. 20-year deal with Constellation Energy. 1,100 megawatts. That's the entire output of one nuclear plant sitting in Clinton, Illinois. But that's just the opening move. Meta has since put out requests for proposals covering up to 6.5 gigawatts of brand new nuclear capacity. 6.5 gigawatts. From a single company that 3 years ago had never signed a nuclear deal in its entire history. 4 of the biggest tech companies on the planet, all racing at the same time into an industry none of them had ever touched before. But here's where the story gets genuinely uncomfortable. Not everyone chose the nuclear route. xAI, Elon Musk's AI company, built something called Colossus in Memphis, Tennessee. It's now one of the largest AI training sites on the entire planet. Roughly 2 gigawatts of power, over 500,000 GPUs, all running together. So how are they actually powering something that massive? Gas turbines, dozens of them, installed fast, in a matter of months. Some of them, reportedly, without going through the normal permitting process first. Local residents in Memphis, in a historically underserved part of the city, say they didn't even find out about the project until they saw it announced on the local news. Environmental groups now describe it as one of the largest single sources of smog-forming pollution in the entire city. The dispute ended up in federal court, and here's the twist. The Justice Department actually stepped in, on xAI's side. Their argument? Colossus now supports national security applications important enough to override some of the usual environmental concerns. So on one side, you've got patient, 20-year nuclear contracts, worth billions, quietly signed years in advance. On the other side, you've got speed. Gas turbines, real local backlash, real lawsuits. 2 completely different paths. Chasing the exact same thing. Enough electricity to train the next model. And the one after that? Now, let's be genuinely fair for a second. Because nuclear isn't some easy magic fix either. New reactors take years to build, sometimes over a decade, start to finish. Even just restarting an existing plant like 3 Mile Island took roughly 3 years of preparation before a single watt could flow again. Small modular reactors, the exact technology Google and Amazon are both betting on? Nobody on Earth is actually running one commercially yet. Google's first Kairos reactor isn't even expected online until 2030, at the earliest. Cost is a real problem too. New nuclear power costs several times more per unit of electricity than a comparable natural gas plant. These 20-year deals only make financial sense for one reason. Tech companies are willing to lock in that long, paying nearly double the standard market rate just to guarantee the power genuinely shows up on schedule. And there's a deeper risk sitting underneath all of it. What if AI progress slows down? What if the next generation of models simply needs less raw computing power to run? Then some of these massive, decade-long energy bets could end up looking like a serious, expensive overbuild. There's one more thing worth mentioning, honestly, too. All of this new demand doesn't stay contained to tech companies alone. In regions with heavy data center construction, ordinary households sharing that same electrical grid have already started seeing their own monthly bills climb, faster than the national average, well before any of them ever typed a single question into ChatGPT. So this isn't some clean, guaranteed happy ending. It's a genuine, expensive bet made by the richest companies alive today, on the assumption that demand for AI and electricity keeps climbing indefinitely. So step back for a second. Look at where this whole story actually started and where it's ended up. A few years ago, the AI race looked like a battle over algorithms. Then it became a battle over chips. Now, in 2026, it's become a battle over something far older, far heavier, far slower to build: electricity itself. The next major breakthrough in artificial intelligence might not happen inside a research lab at all. It might happen at a power plant, one that got shut down years ago, sitting there quietly, waiting for someone rich enough and desperate enough to finally flip the switch back on.